So question 1 is asking us to find the flux of the vector field F through the following surfaces over the given region. So I'm going to do question A, and we're given the vector field y, x, z, and the surface is z equals 4 minus x squared minus y squared above the xy plane, or over the xy plane. So before we begin, let's just remind ourselves what the flux is. Flux through a surface. Okay, so we're going to concentrate here on how to work it out. I've got other links to other videos where you can actually talk about the physical application of flux, but we're just going to concern ourselves with how to find it here. Okay, so it's the surface integral of the vector field dotted with the unit normal to the surface, calculated over the surface, so the integrals over the surface. Okay, so remember last week that ds, so when we were looking at surface area integrals, is equal to grad f, or the modulus of grad f, dA. Okay, so, and remind ourselves that n hat is equal to n over the modulus of n, and remember n is grad f, so it's grad f over the modulus of grad f. So what happens is that this flux integral simplifies to be the surface, over the area, so S is over the surface, A is the area on the xy plane, of F dotted with the normal vector, so not the unit normal, dA, because the modulus of grad F from the unit normal cancels with the grad F from the ds. Okay, so it's going to be just F dotted with N dA. So we really just need to find the area on the xy plane that we're integrating over and make this calculation, and then we can perform our integral. Okay, so the first thing we need to do is find the area on the xy plane that we're integrating over, or our region A. So find region A. So there'll be some x limits and some y limits, or we might need to make a change of coordinates. So to see if we need to change of coordinates, we need to just sketch this graph quickly. Okay, so that's my y-axis, my x-axis, and my z-axis. Okay, so 4 minus x squared minus y squared looks like this. It's a paraboloid, so we get like a parabolic bowl in the xy plane, xyz plane, xyz axis. Okay, so when z is equal to 0, we're on the xy plane. Okay, and the equation of that line, or that circle on the xy plane, is going to be x squared plus y squared. So z is equal to 0, so I brought x squared and y squared to that side, equal to 4. So it's a circle of radius 2. So it's going to pass at 2, etc. Alright, the next thing we need to do, so our area is going to be, it's a circle on the xy plane, so we're going to need polar coordinates. So we need to find limits on r and limits on theta. Alright, so r is going from the origin out to the edge of the circle. So it's going to go from 0 to 2. And theta is going all the way around, so from 0 to 2 pi. Okay, so the next thing we need to do now is find grad f, or the normal vector. So we need to find that normal vector. Okay, so f is equal to z. Okay, so we let f equal to z, and we rewrite this all in terms of f. So it's f is equal to, so we remember we get all the x, y's, and z's onto one side. So it's z plus x squared plus y squared. So grad f is equal to 2x, 2y, 1. Okay, so remember at this point we just need to check if it's positive or minus 1, so to know that we have the right direction. Okay, because there's two unit normals, there's one going that way and there's one going inwards as well. So it's positive 1, so that means we have the outward normal, and that's what we need to just always check. This is the outward normal. Okay, given by the positive 1 here. If there's negative 1, we just times it by negative 1 and times the whole thing by negative 1, so that this will become a positive 1. Alright, so the next thing we need to do is find f dotted with the normal. So remember, this is equal to the normal. So it's equal to, so f is equal to yxz, yxz, and the normal is equal to 2x, 2y, and 1. Okay. So it's equal to 2xy plus 2xy plus z. Okay, so that's equal to 4xy plus z. Okay, so now we're ready to do the flux. So the flux is equal to, the limits on a, which is 0 to 2 pi for theta, and 0 to r, or 0 to 2 for r. So the function f dotted with n, which is 4xy plus z, and don't forget the r, dr, d theta, and the r is from the Jacobian. Okay, so now it's in terms of x, y, and z, so we need to change those. So it goes from 0 to 2 pi, 0 to 2, 4 times, well, 0 to 2, 4 times, okay, what's x? Well, remember here we're in polar coordinates. We made a change to polar coordinates. So x is equal to r cos theta, and y is equal to r sine theta. Okay, so it's going to be x times y is going to be r squared sine theta cos theta plus z, which is equal to 4 minus x squared minus y squared. 4 minus, and I'll write it like this, x squared plus y squared, dr, no, r dr d theta. Okay, so what's the next thing we need to do? 2 pi to 0, 0 to 2, and here I'm going to have a 4 r squared sine theta cosine theta. So that should all be multiplied by r. So plus 4 minus x squared plus y squared. If you work it out over here, x squared plus y squared is equal to r squared. Okay, you should just remember that result. You can show it for yourself if you want by expanding out or squaring this and adding this squared as well. You'll find you get r squared. So r squared times r dr d theta. So that's equal to 2 pi to 0, 2 to 0, 4r cubed sine theta cosine theta plus 4r minus r cubed dr d theta. So now we're ready to integrate. So it's equal from 0 to 2 pi. Ready to integrate, beg your pardon. So out of the 4 sine theta cosine theta plus 2r squared minus a quarter r to the 4 from r equals 2 to r equals 0 d theta equal 2 pi to 0, sub in r equal to 2, I get 2 to the 4, which is 16 sine theta cos theta, plus 2 squared is 4 times 2 is 8, minus 16 on 4, which is 4. Zeros will just give me 0. D theta is equal to 0 to 2 pi, 16 sine theta cosine theta, plus 4 d theta. Okay, so that is equal to, well, cos theta is the derivative of sine theta, so it's going to be 8 sine squared theta. Okay, so make sure you're comfortable with integrating trig functions, plus 4 theta, from theta equal to 2 pi, theta equal to 0. So we're going to get here, well, 8 sine of 2 pi squared. Well, sine of 2 pi is 0, so that's just going to be 0. Here I'm going to get an 8 pi 2 pi times 4. And the zeros are just going to give me 0. So it's going to be 8 pi. Okay, so the flux through this surface is equal to 8 pi. Okay, so that's how much of this vector field is going out or perpendicular to the normal at every point on the surface added up is 8 pi.